Hi guys, so today we're doing parts of similar triangles, and before we get started with our first example, let's talk about the perimeter of similar triangles. Right? So what we know about similar triangles is that if two triangles are similar, then the perimeters are proportional to the measure of the corresponding sides. It means that it has the same scale factor, they are proportional, right? So if it's 2 to 3, then the perimeters will also be 2 to 3. Right? Okay, so let's start with our first example now. So here we have two triangles. We have triangle GHK, and we know that it is similar to triangle TVW. Okay, TV is 35, VW is 37, and WT is 12. Okay. KG is 5. We want to find the perimeter of triangle GHK. Okay, so let's match corresponding parts. So this goes with this. This goes with this. And this would go with this. Right? Okay, so we know from here that it's 5 over 12. Right? So then the perimeter of this, so perimeter of triangle TVW would be 37. So perimeter is 37 plus 35 plus 12. Right? So 37 plus 35 plus 12 gives us 84. So the perimeter of our bigger triangle is 84. And so what we know is that when triangles are similar, okay, the perimeters are proportional to their sides. So if the sides are of a ratio of 5 to 12, the perimeter would be the same thing. Okay? So then we don't know the perimeter of GHK, so we're going to solve it. 12 times x equals 5 times 84. Okay. 5 times 84 is 420. Okay. And then divided by 12, it is 35. So the perimeter of GHK triangle GHK is 35 units. Right? And so what we know is that this, if we were to find all of the sides, this is 175 over 12. Right? And this is 185 over 12. And so if we add all of these sides together, we end up with 35, right? So if I also just found each side using what we've learned before, we would see that it also works, okay? But this is the shortcut, so that way we don't have to find every side, okay? So why don't you try CYP1, and then once you're done, come check your answer. Okay, you should have gotten that the perimeter of triangle DEF is 12.75 units. If you got that right, you can move on to example 2. If not, here is your explanation. Okay? So here, what corresponds is we know EF here corresponds with FH, so then that's 6 over 4. Okay? We know the perimeter of GFH, right? So that's 2 plus 2.5 plus 4, which gives me 8.5. Okay, so that's the perimeter of GFH. Okay, so note how this is triangle GFH stuff on the bottom, triangle DEF stuff on top, because I need to match, right? So then Y would be the perimeter of DEF. Then I cross multiply for Y. 6 times 8.5 is 51. Divide by 4 on both sides. That gives me 12.75. Okay. Okay. So now, before we go on to example 2, let's talk about several more theorems. about similar triangles. So if two triangles are similar, then the measures of the corresponding altitudes are proportional to the sides, right? So QA, that's the altitude in this triangle, over UW corresponds with PR over TV, QR over UV, and PQ over TU, right? Likewise, if two triangles are similar, then the measures of the corresponding angle bisectors, so these are the angle bisectors, are also proportional to the corresponding sides. So QB angle bisector over UX angle bisector is proportional to PR over TV, QR over UV, and PQ over TU. Okay? And then last one here, before we get to our next example, is that if two triangles are similar, then the measures of the corresponding medians, so median again is from vertex to the midpoint, that is proportional to the corresponding sides. So QM, the median here, and UY, okay, so QM over UY is proportional to PR over TV, QR over UV, and PQ over TU. Right? Okay, so now we are going to write a paragraph proof for the one about the corresponding altitudes. Okay, so here we're going to use a picture to kind of help us. Okay, so triangle ABC. Oh, sorry, I was reading the wrong part. Yeah, triangle RTS. We're doing it for angle bisectors. Sorry, triangle RTS we know is similar to triangle EGF. TA and GB are angle bisectors. We are going to prove that TA over GB is equal to RT over EG. Okay. So let's get started. Okay. So first we're going to state that because corresponding angles of similar triangles are congruent, because corresponding angles of similar triangles are congruent, we know that angle R is congruent to angle E, and angle RTS is congruent to angle EGF. Okay, so then let me mark that. So angle R is congruent to angle E, and angle RTS, which is this whole thing, is congruent to angle EGF, this whole thing. Okay? So since angle RTS and angle EGF are bisected, we know that half of one of them, so half of the measure of angle RTS, should equal half the measure of the other one as well. Yeah? Or another way of saying that is that the measure of angle RTA is equal to the measure of angle EGB. Right? So RTA, this one here, would be equal to EGB because each of them are half of their own angles and those original angles were congruent. Okay? So then, what happens then is this makes angle RTA congruent to angle EGB, right? Because if their measures are the same, that means they're congruent. And so as a result, now that we have this pair and this pair being congruent, we can prove that the smaller triangles, triangle RTA is similar to triangle EGB by our angle similarity theorem. So, and if they're similar, that means their sides are proportional. So thus, TA over GB equals RT over EG. And there you go. Okay. So why don't you try CYP through 2 on your own? And then once you're done, come check your answer. Okay, you should have gotten something similar to this. And so as I'm reading it, I will explain it to you. Okay, so since triangle ABC is similar to triangle PQR, we know that from the given, then we can say that angle A is congruent to angle P, right? Because part of being similar triangles is that corresponding angles are congruent, right? Then angle BDA, so this angle here, is also congruent to angle QSP because they are both right angles created by the altitude, right? So remember, altitude is from vertex to the line on the opposite side and creates a 90-degree angle, okay? And so here, since they're both right angles, we know that all right angles are congruent, and so that's why these two angles are congruent. Yep, here, okay? As a result, then, triangle ABD, this part here, this triangle here, is congruent to triangle PQS by angle-angle similarity, right? Angle, 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 okay? And as a result, then, BD over QS has to equal BA over QP by the definition of similar polygons, right? Because definition of similar polygons is that the corresponding sides are proportional, right? And so there you go. Okay, so now let's move on to example 3. Okay. So here's example 3. So in the figure, triangle ABC here is similar to triangle DEF. BG, so this is a typo, sorry. So BG is a median of triangle ABC, and EH here is a median of triangle DEF. Okay, so that means part of median is vertex to the midpoint. So this is congruent, and this is congruent. Okay, we want to find EH. We want to find what this is. If BC here is 30, BG here is 15, and EF here is 15. We want to find out what this is. Okay, so here what we know about medians is that they are also proportional. So then I'm going to match the corresponding stuff. So this 30 goes with this 15, and this 15 goes with my unknown. So now let's match it. Okay, so I'm going to do 30 over 15. Right, so note here, it's what I highlighted in pink. 30 over 15 equals, since I did this one first and on top, then this has to be first, 15 over my unknown. So let's just say x. Okay. Then let's cross multiply. So then 30 times x is 30x. 15 times 15, 225. Right? And then I'm going to divide by 30 on both sides. And this gives me 7.5. And so what that means is that EH is 7.5 units long. And there you go. Okay, so why don't you try CYP3, and then once you're done, come check your answer. Okay, so RT is 3 1/3. Okay, if you got that right, you can move on to our last example. If not, here is your explanation. Okay, so here we have two similar triangles, and then we're given the altitude of each of them, KM here and RT here. Okay, we're told that JL, so this whole thing is 12, QS, this whole thing is 8, KM, this altitude here is 5, and we want to figure out what the altitude is for the others. Right? So part of our similar triangles theorems for the altitude, it tells us that if they're similar triangles, the altitudes are proportional to the sides as well. Okay, so that means 12 over 8 is proportional to 5 over this unknown here, which I labeled as y. Okay. Then I just need to solve the proportion by cross multiplying. So 12y equals 5 times 8, which is 40. Divide by 12 on both sides, so 40 over 12. They're both divisible by 4, so then it becomes 10 over 3. And then 3 goes into 10 3 times with 1 left over, so 3 and a third. Okay, moving on to our last example. Okay. So the drawing here illustrates the position of the camera and the distance from the lens of the camera to the film. And then we want to find the height of this sculpture. Right? So we're going to match corresponding parts. Right? So I'm going to match this length here, this 35, with this over here, this unknown. Okay. Then I'm going to match this 42 here with this 6.16. Right? Okay, and then let's set it to solve. So 35 over x equals, so since I chose this one to be top, then I have to make this the top, 42 over 6.16. Okay. So this is how I matched it. Right. So it works because this is the camera one and this is the sculpture. So it's still okay. You can see that the book did it a little bit differently from mine, right? But theirs matches too. Okay. It's just I did vertical and I just switched the order. I just put the X on the bottom and the 6.16 on the bottom, and whereas they put it on top. Okay. So then let's cross multiply. So this becomes 4.2. Oh, sorry, not 4.2. 42x equals 35 times 6.16. 35 times 6.16 is 215.6. Then I'm going to divide by 42 on both sides. And this is approximately 5.13. Right? And so this, since this was in meters, the sculpture is about 5.13 meters tall. There you go. Okay. So why don't you try CYP4, and then once you're done, come check your answer. Okay, so the fountain is 3.51 meters away from the rose garden. Okay. If you got that right, you can move on to your homework. If not, here is your explanation. Okay. So here we have similar triangles. Right? So I just matched what it corresponded to. So this 6 here corresponds with this 7.8. So 6 and the 7.8. Okay. And then this 2.7 here corresponds with this unknown. Right? Right. You could have also done 6 over 7.8 and 2.7 over x. That's fine as long as you're consistent. Okay. Then I cross multiplied, so 6 times x, 2.7 times 7.8, which is 21.06. Divided by 6 on both sides, I got 3.51. Okay. So that's it for today. Have a great rest of the day. Bye, guys.